First Spin. Welcome to First Spin, a show where I learn about how to use the parallax propeller without having any prior programming experience. And rather than do this on my own, we have come back full circle to our two experts. How was your week off, Mr. Roy?
It was all right.
Just all right? You missed us, didn't you?
No.
It was a lonely
I
existence.
I listened to the show the very next day.
Did you like it?
He was a sad puppy.
No,
Micromedic.
it's all right.
He totally would have loved coming on and hanging out with Ken.
I got a little nervous. I'm not gonna lie. I was a little excited, and I think because we're talking about medical things.
You did sound a bit nervous at the beginning, but
right?
You got more comfortable as
did
it
I?
went.
All right.
I don't think I could get nervous because Ken's such a nice guy.
Well, yes, they are very nice, but they are still.
I've had hamburgers with the doctor, so yeah.
That's true. You did sit next to him.
Both of those guys are really nice guys.
Yes. I completely agree. I was like,
really
oh
smart
man,
people.
I have to pretend to be smart in this one because I'm a nurse.
Well, the one thing I will say is Ken didn't really say a whole lot. He was pretty quiet.
Yeah, that's because Doc was really excited. So
yeah, well, it's kind of Doc's baby, from what I understand.
That makes sense.
Maybe I'm wrong, but it seems like he's been wanting to do something like this for a while.
Well,
and I'm excited about it at the last expo.
Yeah, and I'm kind of tempted because I ran a suggestion or an idea, and they seemed supportive of said idea.
Oh, after we were recording.
Yeah. So I don't know. I kind of want to enter it. It'll give me a goal for that project.
So if you guys have absolutely no idea what we're talking about, go listen to the show from last week.
Yes, Micromedic. Yeah. Parallax.com learn.parallax.com/micromedic will take you to all of the details.
Yeah, there's another piece of news too with the expo. It's kind of changed up.
What? This is new? This is new to me. Okay, wait, what?
Well,
what's going on?
The expo, which was gonna be that kind of the robot contest thing with the university nearby and all that, has now turned into, on May 4th, they're going to have the official Propeller Expo.
I don't think they're calling it expo. I think they're calling it conference.
Yes.
Maybe conference, whatever.
Wait, Parallax Conference?
Who is it? Lauren? I think I saw a tweet about it.
Yeah.
Yeah, so it's basically turning into more like what UPEW was. It'll be at their office in Rockland. It'll be geared more towards like the programmer geeks and the hackers and makers and whatnot. And then at a later time, they're going to schedule a second event, which will be the robot competition more towards kids and education.
So and by later time,
what the date is that there's going to be like a broom closet that I can hang out with a bunch of nerds.
Right. Okay.
Because that was cool.
May 4th.
That's May 4th.
Okay.
And they're still going to have the thing on the Friday before.
Okay.
Where there's going to be like a reception thing, and
I think we had barbecue last year.
and well, but they talked about something like from sometime in the early evening, like 4 or 5 in the evening, until pretty late at night, hanging out at Staybridge. So
cool.
They may have gotten the room or something. I really don't know. They were planning on releasing more details, and I haven't seen anything new yet.
Okay, so let me double check. Is it at a later time, as in like a completely different week, or at a later time, as in the next day?
Completely different, like months later.
Oh.
Like they're talking about later in the year.
Oh, I see. So like for better weather, maybe, or
I don't know. Maybe something came up with the university they were planning on locating it at, or maybe they decided to have the UPW thing now and that thing later.
Okay.
Separate.
So
I don't really know.
As of now, the latest details is Saturday, May 4th. It's going to be at Parallax headquarters
in Rockland. Yeah.
In Rockland, and it's going to only be there. Right. I think that sounds like a lot more fun.
The Friday before at the Staybridge, which is like right around the corner.
Right.
I'm surprised that Staybridge is letting us come back after Addie hacked their telephone system and Joe Grand and I streaked through the parking lot.
That didn't happen.
I don't think we did it.
Maybe that was a dream.
I do, however, remember that guy who does a lot of special effects. Who's that? What's his name?
The paint gun guy.
Yeah,
I know
paint
you're
gun
talking about.
guy. What's
I
his name?
forget his name. I think it's Rick.
Rick.
something.
Rick. Yeah.
Paint gun.
He
That's
got
what
yelled
it
at
He
'cause he was
hooked his
hacking into their
computer
TV.
into
Yeah.
their TV in the lobby, and he was showing us slides, and we're like, "Whoa, this is so cool!"
It was at
But
like
it was like
3 in the
3.
morning too.
Oh, you
They
hooked his
told us to go
laptop
to
up
bed.
They said, "Shh, there are guests here."
Yes, we are here. We're playing with your TV.
That was.
I forgot about that.
Yeah.
Into
Oops.
the slides.
We'll be better, guys.
We totally won't. We'll probably be more entitled this time.
I was very surprised at how many other non-Parallax guests there were. What are people doing in Rockland, California on on a like
One thing to keep in mind
Friday?
is that Staybridge place is sort of a long-term living kind of long-term temporary living.
You're right. We did
So,
meet
like,
somebody.
So there's like a lot of college kids that live there
What?
for months at a time.
For
Yeah.
school?
Well, they live in that place as
That's too much money.
as their residence.
Wow.
Or there's just other people that are visiting and they live there for like a month or 2 months at a time. So some of
Wow.
that is that.
Wow.
It's like a residence inn or that kind of thing.
So we're like the hooligans. We're the nerd hooligans.
Yeah, we're the
You
temporary
punks.
passerbys.
You Parallax punks, you.
We're like the rock band that shows up and throws the TV out the window.
That's awesome.
Mm-hmm.
That is awesome. I should totally get some like sunglasses and wear them inside while it's dark.
Joe totally did run. I don't know if he was naked. That may have been in a dream. But
Awkward.
yeah.
Kids
He
listening.
does run, but he wears his running shorts and t-shirt.
Oh gosh, that 80s one. Okay. Anyway, so we are back to interpreters, and I'm happy to say that even though my best attempts to forget what the assignment was
We forced you to remember
failed.
a few hours ago.
Yeah, well, I might have started this assignment a little late, but it got done. See, by the deadline, it got done. So the assignment was to add a command or add more functionality to the interpreter. So up to this point, Whisker and Roy have been the ones adding finesse and class to byte.spin. And it is up to me to completely ruin that with Booga Booga. So we'll take a look at these files. I don't know, which one should we start with? Should we start with what the new program looks like?
All the files she's going to refer to will be linked to in the show notes for
Right.
you guys to follow along.
Yeah.
Right. So
We could start with the description one, I think,
Yeah,
because it's
that's a good idea.
closest to what we talked about 2 weeks ago.
That's a good idea.
And we can talk about the primary difference, which is you replaced one sequence of characters with a new command.
Right. So if we look at the program description, I remember Roy saying that any of the long strings of like bracket, minus, plus, minus, all that nonsense, pain, could be essentially condensed into a single command. So I was like, all right, I'll look.
So I was thinking along the lines of like the one that does the conditional jump to one of two places. You could do that as a command or a couple of commands instead of the 8 characters or 7 characters that it is.
Right. But
you went a different route.
I went super
she took this idea a little bit liberally.
Well, I looked at what the longest string of gobbledygook was, and it just happened to be the move memy to mmz while adding memy to mt. I mean, and in my brain, that's pretty easy. I just set.
I think I recall us actually talking about doing something with this particular line.
You see?
Some commands also.
I pay attention.
Implementing an accumulator is what I brought up, but that's a little bit
Right.
different than what she actually did.
Well,
Yeah.
whatevs. So
She basically made a command to do this whole sequence of move mem y to mem z while adding mem y to mem t.
correct. And I
Then-
decided
yeah.
to call it Command C for crazy. Because y'all's are crazy.
No, because you're crazy.
I'm crazy too, but y'all's are even crazier. See, my mentors. All right, so that is what I decided to do. And so if you look at the top, the first line is the original program for the multiplication program that Whisker wrote, and then the second line, you see, isn't that nice little that gobbledygook's all taken out and a little C is in place.
Yeah.
Do you
So
see
you're
the
shortened
C?
by what, 10 characters approximately?
Mm-hmm.
Something like that?
Yep.
8 characters, 10, something,
8.
whatever.
8. Yep. So actually, in the memory, when you go to put it into the actual program that you're going to execute, you want to do enter multiplican, hit enter, enter multiplicator, hit enter 0, 38 instead of 46.
Mm-hmm.
And then 18. And then that'll bring you to the right
Yeah.
jump location.
Because she changed the length of the program, she changed the ladder jump points in
Correct.
the execution.
Yeah. Correct.
Yeah.
The 18 stayed the same because that was before
the C.
multiplication.
Great.
Yeah.
So, yeah, and actually that was one thing. That was actually one of the last things I changed. I forgot that I needed to change the jump points, and I realized that the program wasn't going correctly because it would give me the, it'll always give me the multiplicand, never the product. So it'd always give me the first number that I wrote in, and I was like, well, this is a useless program.
That was a different bug, though. When you were implementing the C, you forgot to, what did you call that silly variable?
Booga.
Okay, you forgot to add that.
That too.
Yeah. That
was the other thing. Okay, so there's a program description, and then you see in the actual program, byte multiply dot spin. We've changed the trial 3 program there to have the C. I didn't change anything else in the rest of the program. And then if we go back to byte dot spin and we scroll all the way down, I just added C after command E, and essentially I pretty much wrote all the steps. I just thought, okay, step by step, what am I doing? Well, first, when we get to this point, the pointer is looking at mem y. So, so I was like, all right, well, I'm going to set random variable Booga to whatever is in y. And then I'm going to increment, move to z, and then I'm going to set z to Booga. In other words, setting z to whatever was in y.
Right.
Then
so
I'm
copying y to z.
Right. And then I'm going to move to t.
So before you get too far along in that, basically what you're doing, the first step of that anyway, not the whole thing here, is that you've created a command that'll automatically copy something from memory into a register.
Sure. That is correct.
But then it does stuff to it.
Right.
Right.
That is, yes. Register Booga. No.
Yes. Register Booga.
It's a temporary transient register because it's only useful during this command.
And that's fancy talk.
Right. That really is actually quite fancy talk. Okay, so then I incremented the pointer to move to T. Now originally I set T to mem y. Right? But if you look at the actual program, T is the quote total, is the actual product. So so if you always constantly set it to y, then
it's just going to give you that as
it's going to give you that number, which is why I kept getting the first number.
So you had to add y to what was already in T.
Correct. So I did mem p colon equals mem p plus Booga. Booga. And then I did mem p. I went backwards 2 times so that it would go back to mem y, and then I set it to 0 because that's essentially what happens in the original program. It adds, it adds, and then because it's added.
It's adding to z and t and subtracting from y until y equals 0.
Correct.
So you end up adding the contents of y to the other 2.
Correct.
Now, personally, I think that it would have been better to just have it add whatever you were pointing at to the memory address in front of it. Now, there's still problems with doing it that way, But
Yeah.
rather than
there-
do what you did here, I would have gone more that direction.
What do you mean?
Well, for starters, this particular command that you've implemented
It's
is
very
really
specific.
super special case and
Yeah.
will only
It's
really
making
work.
some assumptions.
Right.
It will really only work in this particular program's context
Mm-hmm.
or other programs that have the exact same layout for variables in memory
Yes.
It's
and want to do the
making
exact same sequence to them.
Right.
so it's making the assumption that you've put the memory pointer to the starting byte, right?
Right.
And it's making the assumption that the next 2 bytes after are
Yeah.
going to be used for this exact purpose.
Right.
So this
But that's
command
okay.
No, not really.
it's not a good design choice when you're designing the
suppose.
language, you see.
Yeah.
I mean, it happens to work for this particular program.
But as long as I keep the
But you wouldn't
memories.
really. The thing is that if you were to write a whole new program,
Yeah.
you probably would not use the C command in it at all because it wouldn't fit. You'd
It's
have to
crazy.
make another new special case command to do some feature that you want.
Right. I think at this point I was more like I just want to see if it works. Because
So I mean, this isn't a bad thing because like you've actually added something to the byte interpreter, and it's a new custom command that you did, and it replaced something existing as far as functionality.
right.
But we're just trying to help you understand why it's maybe not the best
Yeah.
example.
Right. And that's the first thing that Whisker said. Whisker's like, that looks a little specific. Wait, you wrote this for this program, didn't you? Yes. I did.
So what I would say is that you're on the right track. I mean, you've proven to yourself that you can change the thing to make it do whatever you want.
Right.
And that's good. Now, the next step to it would be to come up with the real thing that was making that part of it take that many instructions to do
Mm-hmm.
and implement a command that takes care of that rather than replaces something specific in that exact program.
Mm-hmm.
The thing that you're replacing there is just a part of the thing that you're really trying to replace there, which is the whole multiplication thing, the whole accumulator thing.
Right.
Right.
So in other words, instead of trying to take the entire 9-character sequence down to 1-character command to do everything in there, maybe think of changing it into something that's only 4 or 5 commands, where
I'd have to look at
a
it
couple
again,
of the
but I
commands
think
are new
I think
commands.
the sequence that she can replace is actually even longer,
yeah.
and she can replace it with
Potentially.
a single command.
Well,
that-
I could theoretically.
that isn't specific to this program, right?
Couldn't I just
Right.
do a multiplication?
Exactly.
Right.
And you
thing?
could replace
could.
like 15
could-
characters out of there or something.
Right.
Yeah, I mean, you could replace the entire sequence that does the loop adding y to t one at a time for each x, and instead just make a command that takes the next 2 values and multiplies them by each other
Right.
and stores the result in the 3rd value,
Well, yeah. Okay. I see what you mean.
right?
Or a
That-
set
and
of
that's-
So you guys aren't like I mean, I almost want to say are you guys
or
Oh,
a set
what?
of commands that deals with registers
Right.
and acts on them. So you can load the value that you're currently pointing at in memory to register A. And another command that you could load the memory position that you're now pointing at into register B. And a command that will multiply register A and B and put it in register C or in the accumulator or whatever you're calling it.
Mm-hmm.
Right.
And that would be useful for all the programs you want to write when you need that functionality, but it doesn't make any assumptions about where things are in memory. Got
Right.
me?
And the other thing that does is it lends itself to once you've got the commands that load into registers, and you make your multiply command and multiply 2 registers, you can make a divide command that divides 2 registers, and you can make another command that does something else with the 2
Addition,
registers. Right?
subtraction, any of the math functions that you want to implement, and you could very easily implement any of the ones that are included in Spin you could implement very easily right here
Right.
by just, treating register A and register B as the two input numbers into any of these math functions that you can do in Spin, and then taking the result and putting it in a specific register, the same one every time.
And the way to think of a register is basically like your Booga variable. That's a register.
Okay.
Right? You would just need to have Booga 1 and Booga 2, right?
Booga,
Don't
Booga.
encourage her, Roy.
Booga
I'm
and
just
Booga.
saying you could have those two could be your registers, and you just have commands that assign the current memory pointer to Booga and another command to assign the current memory pointer to Booga Booga, right? And then now you have those two values stored into your registers. Then you can have a third command that takes Booga and multiplies it by Booga Booga and stores it in Booga Booga Booga. Or you could use like Booga 1, Booga 2, Booga 3, like an array.
Now, I have a question.
An array called registers.
I have a question. Can a symbol... Okay, this is going to be weird. Can a symbol be a register, as in, like...
You need to be careful with that symbol word because it has meaning in
I know.
Talking about this
I'm
stuff.
trying to think of how I would write the program if I wanted it to say, okay, enter first number, enter second number, enter first number, hit enter, enter second number, hit enter, and then enter, like, action that you want to do, like, math-wise, like addition, subtraction, multiplication, division.
So what I was saying just a minute ago was that you would have a command for setting whatever you're pointing at into register A. You would have another command for setting whatever you're pointing at into register B. And then you would have a set of commands, and each one of those would do a different math operation. So you might have one to do addition, you might have one to do subtraction, one for multiplication, one for division. And if you enact any of those, it would use register A as the multiplicator, register B as the multiplicand, and it would put the result into your accumulator.
Okay. So
and then you would have a command for copying your accumulator.
Whisker, you're going too fast.
Your accumulator back into whatever memory address you're pointing at.
Right.
You just made me stop my brain. Okay.
I think I know what you were going in the direction of, but how do I let the program let you pick what you want to do?
No.
Right? You were saying I enter the two numbers and then choose the action, right?
Yes.
Do I want to multiply? Do I want to divide?
Yes.
The problem is that we don't have a conditional command that would let you do that
Not yet.
So you would need to add a conditional
I could do
command.
Like P for plus and M for minus.
Well, no. To do a conditional command, you would need to have something that would compare what they typed with something you already had in memory somewhere, which would then let you decide what to do.
A switch or a case, that kind of thing.
Or an if.
If else.
Right.
Huh.
But I think a good first step would just be to implement the register A and register B and the command that operates on them and stores the results in an accumulator, and then a command to write the accumulator back.
Okay. Guys, I need to complete my thought and complete my question. If I put, all right, according to this interpreter, equal sign is where you put in whatever decimal you want.
Mm-hmm.
Okay? So if I did equals and then you put 5, right?
Right.
And then, so equals, and then I would go to the next execution point, and then say I put R for register 1, okay? Then I could...
In the program or as user
in the
input?
program. So it would look like equals right caret R.
Okay.
Okay? And then...
Well, hold on. Right caret moves the memory address up 1, though, so...
Oh, wait.
You need to do the R first, right?
No. Wait. Yes, sorry. I'm trying to figure...
In fact, you don't... If you're going to put it in a register, then you don't even need to do the right caret. Because you don't need to move to a new memory address.
Right. Okay. So, sorry. So,
So equal sign
equal
R.
sign R, right, would
Load whatever they typed
load whatever they typed
into
into register.
their
Register.
register.
And then
Although
I would
might I
do
suggest you say A for register A instead of R for
Sure.
register?
Sure, I could do that. I'm just
'Cause then you could
I'm
do
just trying to
B
think.
for
So
register B.
so equals R right caret equals equals A right caret equals B.
Well, you don't need the right caret at all.
You're not moving through memory. You're writing these things directly to registers.
Oh, so you could use the same. I always forget. You can use the same
equals
MP.
A and then equals B. Just equals A equals B would put the two numbers into A and B.
Oh, right.
And you're just temporarily
They're like
using
temp variables.
Right.
Ooh. And then I could choose the multiplication, division, whatever. And it
Right.
would take those two numbers and just do it. So I could do
Well, you need to also internally in the interpreter, you need to have a place to hold the result. Like where does it put the answer as a register? It needs to be
Right.
another register.
So it'd be equals
Or
A
or
equals
it needs to
B
write it to the
And
current
then
memory
an
address.
asterisk.
asterisk for multiplication.
And then
So-
you would read the value back out of the accumulator into memory so you could print it out.
Right. So like I was about to say though, is that you could do two things. You could have an internal accumulator, or you could have the asterisk which does the multiply. It could just write it out to the current memory address. The result.
Yeah. And in that case,
would
you'd
also
want
work.
like a greater than or less than sign, but you don't need to. I mean, you could have it write it directly to the one that you're sitting on at the moment. So,
Right.
you know, you do your equal sign, it puts it into that address, and then you do your A, it loads it up into the register. Your equal sign, it loads it into the same memory address. You do B, it puts it in register B, and you do your asterisk to do multiplication, and it puts the result right into the memory address you're pointing at, and then you print it out with
The print command, right? The question mark, I guess, or
Right.
the pound, whatever it is. I forget the commands.
Pound for
Been 2
decimal,
weeks.
yeah. So I should not limit myself. The point is I should not limit myself to these masochistic commands.
right.
I should
Right.
create more commands so you guys do not have as much power over my code.
Where there is pain, that's where the change needs to happen.
Oh,
Right.
Now, what we're trying to get in your
I
head
see.
is recognizing this, right?
okay.
To gain that seventh sense, right?
Mm-hmm.
Where you can feel where it's not as easy or elegant or as nice as it could be,
Mm-hmm.
and then to focus your brain on, okay, what's the real problem underneath that's causing it to be that way, and then wipe it off the face of your code.
Is this kind of like the basis of object-oriented programming?
No, but we'll
No.
get there.
Well, because
So just so you know, I just was looking.
yeah,
You would replace about 90% of the current program
yes,
with 5 characters.
correct.
If
Muha.
you implement the commands that we just talked about,
Right.
and it sounds like you get them, and it wouldn't be
Yes.
that hard for you to do. So I think you should do that before next week.
Next week, we
In
want
In
to
fact,
see
I
your
think you should do it
registers.
before it gets to next week when we record.
I'll have time this weekend.
Yeah,
I'll have time this weekend.
just got a couple of days off.
Yeah.
Right.
All right. You know what? I accept your challenge because you guys have pretty much given me the answer. So I'll take it. All right. I think I'm getting it. I think it's just a matter of realizing that I'm not limited to you. And I know you guys have said this, but just realizing I'm not limited to using your crappy
Right.
commands.
This was just a let's get it started so you can see how one works.
Right.
And now you need to go make it much better.
Right.
And when designing new commands, always remember you're not replacing the functionality of a big group of code. You're creating functionality that makes it so that you don't even need
That code.
that big group of code, right?
Right.
But it has to be something that is usable,
Usable.
and reusable.
Right.
You know, it's
Right. You want it to be
non-specific.
generic.
Right.
Generic is a great word for it. But
Right.
we're out of time, guys.
Dang.
That's it for this week. We'd like to hear feedback from you guys. Let us know if you guys are enjoying this or hating the direction that this show has taken. Because we don't know. You guys don't let us know. And we're just going to keep on keeping on until you guys tell us otherwise.
Until I have made a all-new interpreter for Spin.
Seriously, we're on the forums at Parallax. We're on Twitter. Email us feedback at tymkrs.com. There's lots of ways to get a hold of us. We want to know what you guys are thinking. We want feedback. If you guys
even
have
jump on the IRC.
Yes, there's also the chat. We're always in there. So
Always.
Yeah. We need more propeller people in there too. It's getting a little stinky with the
to Arduino and pick pick an AVR.
Yeah. So anyway, that's it for us for this week. You guys can find this show every Tuesday at firstspin.tv. There's an RSS feed there too if you want to have it automatically downloaded to your phone, your iTunes, whatever. Or of course you can listen to it there on the page. That's it for us. We'll see you guys next week.
Ciao.
See ya.